Hi, everyone, and welcome to the AWS Nordics Office Hours with me, Gunnar Grosch, developer advocate here at AWS, based in the Nordics in Sweden. And this is our weekly show where I bring AWS experts on to talk about specific topics and, well, then let you, our viewers, ask any questions you might have. And hopefully by the end of this hour, we've all learned something new. And we want to make this super interactive. So post any questions, comments you have in the chat, and we'll try to pick them up. And hopefully my guest is able to answer them as well. So this week, I'm super happy to be joined by my teammate, Viktor Vedmich. Welcome to the show, Viktor.
Hello, Gunnar. Hello, everyone. My name is Viktor Vedmich. I am based currently in Germany, in Munich. And also, as Gunnar said, I am team member of DevRel team, and my focus mostly is related to Kubernetes. And honestly, just like I really enjoy when Gunnar say, "Hey, can we speak about Kubernetes and Nordic Office Hours?" I say yes, and I have very great topic. It's Karpenter. Karpenter, very great tool, and I think we will speak about today during this whole hour and deep dive with a demo and all of this stuff.
Super excited to finally have you on, Viktor. I've been trying to get you on for a while, but now it finally happened. So hi, everyone in the chat. I can see a few messages already. I see we have viewers even from the United States. So good morning to you and good afternoon to everyone on, I guess, this side of the Atlantic. All right, so you already mentioned what the topic is, Viktor. We're going to talk about Kubernetes and we're going to talk about Karpenter in particular. And maybe just a few words. Give us your quick introduction to what Kubernetes is to begin with, Viktor.
It's very difficult to be very
putting you on the spot. I know, but let's give it a try.
Kubernetes, it's sometimes I heard the story that currently someone say Kubernetes it's a new Linux, because when we started to think about develop some application, we think that Kubernetes it will be our platform where we are going to deploy our application. In general, Kubernetes is open source product, and a lot of realization you can find. For example, you can install Kubernetes in your on-premise solution, or for example, in AWS we have EKS, and like managed service from your side. You don't need to worry about control plane and all of the stuff. Mostly Kubernetes, very great fit if you have some microservice application. Some of you would say Kubernetes is not good fit for stateful. I will not very agree with you. I believe Kubernetes currently is pretty fine to manage your stateful applications like MySQL, for example, or Mongo or some other products. But in general, if you have some microservice application, Kubernetes will be one of the best solution, because it's pretty easy to start and continue if you need to scale in multiple thousand, millions nodes, pods, and all of the stuff. And yeah, today we will speak about scaling specifically.
And great to have you be opinionated straight away, say that Kubernetes is one of the best options for microservices. We might have some viewers that disagree, but I guess we'll see in the comments. So there is a quick question about Kubernetes to begin with, Viktor. So let's do that straight away. From Puri93, what is your preference of deploying EKS? Terraform, CloudFormation, or how do you say it? Do you say EKS Cuddle
CTL.
or CTL?
Cuddle, yeah, like I think so. My preference will be Terraform. And in 2022, we not like released, we developed blueprints with Terraform where you can manage your installation of Kubernetes. And recently, we updated our EKS workshop. It's fully fresh, like version 2. We updated a lot of materials there. And if you're not very familiar with Kubernetes, I believe it will be a very great start to do it. Like go through this workshop where it's also covered by Karpenter. And, the guys also recommended Terraform and blueprints to deploy and manage your Kubernetes installation as EKS inside AWS.
Yeah, and I guess that answered the second question we got from Rupla. As someone who's totally new to Kubernetes, what is advised to get hands dirty and get it going as fast as possible? And you mentioned the EKS workshop.
100%. It's like covered everything, almost everything what you needed, and started from the like basic stuff like 100 and finish with 300-400 level service mesh, scaling, observability, monitoring, everything. Just start do your like AKS workshop, and like I don't know. During the next week, you will learn a lot about Kubernetes. Not theoretical stuff, but mostly practical.
Very cool. I'll post a link in the chat in a while as well. So, Viktor, then let's move on to the topic of today, Karpenter. And you mentioned that it is about scaling Kubernetes. So, tell us a bit more about
that. Question. Maybe I should share my screen or.
Yeah, let's do it.
Yeah. So in general, today we are going to speak about Karpenter. Karpenter is a scaling mechanism for Kubernetes. But what kind of scaling do we know, and just like what exactly we can do with scaling? It's very familiar to cloud. When we select a cloud, first of all, we think how we can scale. And let's review two possible ways how we can scale. The first one is horizontal, when we need add additional instances, like for example, in Kubernetes, the smallest part of our instances is a pod, which combine a couple of containers. But in general, we manage and working with pods. It's our smallest part. And for example, I have my web application and I need only one pod because currently I have only, I know, a couple of customers. But tomorrow, just like my application stays very popular and I need to scale my application, a scale count of amount of pods. And it means like I scale horizontally. I add new pods. And for example, during some high load, I don't know, like Black Friday, or I release new functionality or deploy some new version, which can be very popular for my customers, I can scale to add additional pods. It's one way. Another way, it's very familiar. It's the same when you want to scale your instances. You can add more and more instances, and it's called like horizontal because we can do it pretty quickly. We are not limited of some amount of resources, for example, hardware and so on. Another one is vertical pod scaler, and like from the naming, you understand we scale in vertical way. In the vertical way, it means like I start with very, very small pod. Like for example, in my case, one CPU, it can be 100 millicores of CPU, doesn't matter, but it's very small. But I understand for this current load, for this current request, I need to scale, but not in horizontally because, for example, this particular application is not very good to scale horizontally to add additional instances. It's much better to scale vertically to change the size of my pod. Like for example, 2 CPU or 8 CPU or I don't know, like 32 CPU, just like depends. But yeah, it's two main approach how we scale inside the Kubernetes. I mean, like it's not we add additional resources. For example, my Kubernetes installation has, I don't know, like 10 nodes, for example, yeah. And I can use horizontal pod scaler and vertical to manage my load inside the Kubernetes, but not add additional load. Yeah, and when, for example, I have to extend amount of resources for my Kubernetes cluster, the current most common solution is cluster autoscaler. It's very popular. I believe if you're familiar with Kubernetes, you definitely work with cluster autoscaler because it's also open source product and part of Kubernetes solution. But how this works? What exactly happened when I need to add additional nodes? There are 4 main steps. The first one, just like, for example, I got some request of additional load, like deploy a new application or scale my application. And currently, I see a couple of pods in the pending state. Yeah, it's waiting for some resources where we can put my pods. What exactly cluster autoscaler will do? It will communicate with node group. Node group is abstraction layer between ISG. ISG it's after scaling group inside an AWS. And ISG will communicate with EC2. And if you're familiar with ISG, you know like you have to define minimum, desired, and maximum capacity. And also the best practice is select the same type of instances. For example, if you have your load which require 2 CPU, most probably it will be the best way to define some type of instances which has only 2 CPU, I don't know, and 4 GB of memory, for example. But in case if you need another, I don't know, like for example, you decide to deploy some analytics application, and this analytics application required, I don't know, 8 CPU, you have to create additional node group, ISG, and all of that stuff. And as soon as we get this node, we will be able to schedule my application inside this new deployed node. If we look at the visualization part, I mean, like, for example, currently I have 4 nodes, and every node is like, let's say, one small square, it's 1 CPU, and currently I deployed new application, and we are waiting for additional 7 ports. We need 7 CPU to proceed with this load. Cluster scaler, what exactly will happen? Just like understand, okay, inside the Kubernetes, scaler try to find some free spaces. And as you can see, we have 2 free spaces, this one and this one. And of course, we will schedule this free ports on inside in this node. And then it's like what I described previously, we start the procedure to add additional node inside in my Kubernetes cluster. We'll communicate with node group with autoscaling group with EC2, and we add additional 2 nodes. Why 2 nodes? Because we have to provide capacity for 5 CPU, but our 1 node can provide only 4 CPU. And in this case, what we can see and what's the situations happens currently. We have a lot of resources which is idle. We don't use it, and the best solution is the cloud when you use as much as you need it. Like if you have free resources which is not needed, try to find some solution how we can optimize and make sure that we use only what exactly we need in the current load in the current situation. So that's how cluster scaler works. But today we want to speak about Karpenter. And Karpenter, first of all, it's open source solution. You can find it like in karpenter.sh. We started to develop this open source application more than 1 year ago. I remember during the reInvent 2021, we just like say it's production ready. You can start and use it. The current version, as you can see, 0.24. And it's like the team who develops this application, Karpenter, works really, really fast. You can subscribe to new functionality and so on. But let's review what will change if we switch to the Karpenter. The same example, yeah. For example, I have the application which required again 7 CPU, 7 ports. The first step will be absolutely the same. Kubernetes scheduler will try to find some empty spaces, like free spaces, where we can put our load as we already did it. And the next step, what will happen? Karpenter will directly communicate with EC2 API. When I say directly communicate with EC2 API, I mean in cluster scaler, yeah, when we working with cluster scaler, as I said, we communicate with ISG, and ISG communicate with EC2 API. In Karpenter, you don't need ISG, you don't need autoscaling group. Karpenter will manage your nodes by themselves. And when we need to add additional resources, Karpenter understand, okay, in the current situation, I need a node which where I can fit this 5 CPU, yeah. And Karpenter will directly communicate with EC2 API, and we will see in the demo. Ask, can you please, EC2 API, provide for me all of the instances which can fit this load? And the main goal of the Karpenter provide for you just in time the resources what you exactly currently needed, and do it as cheaper as possible. For example, you can manage to say, I'm prefer to use spot instances. Or, for example, it will not select with GPU because it also can fit this load. It try to find some cheaper solution for your current request. But all of the limitation restrictions, what kind of node, we'll review a little bit later. But in general, what will happen in this situation? I need resources for 5 CPU, for 5 pods. Karpenter will communicate with EC2 API and provide only 1 node. It's, let's say, default configuration and how default Karpenter will work. Request 1 node which can fit all of this load. And we put all of this node inside this node. And as you can see, compare with the previous example, yeah, currently we have only one free spaces here, just like much, our consumption resources, what we requested and what we used, we try to fit our goal around 90%, for example. And it's very, very great. From another perspective, when I speak about the Karpenter, it's how we can scale down. Like I finish with my application, yeah. For example, with this one, absolutely the same. Just like I done with this after scaling, and I don't need anymore these nodes, these ports, and this node. Scalar will delete these ports. And as you can see, we currently have some free resources. I mean, like these free nodes, like fully free, and we can delete it. And this will happen. Karpenter run TTL, time to leave, of this node. And as soon as this TTL seconds after empty will finish in like, for example, certain seconds, Karpenter again directly communicate with EC2 API and will delete this node. But in previous year, 2022, we also released a very great feature, and it's called consolidation. And consolidation, it's, from my opinion, it's why I prefer to use Karpenter if compare, for example, with cluster to scalar. I want to make some pause. Maybe we have currently some questions because just like in my current installation, I don't see the screen. Yeah. So
no questions in the chat yet,
okay.
or at the moment. But if you have questions, there we go. We just got one. So how do you integrate EC2 instances with ELB since autoscaling groups aren't used?
Based on the labels. So inside the Kubernetes cluster, you will create, for example, a service. And this service can be ingress as a service or load balancer as a service. And you will not work with ISG, you will work with pod. And for example, depends on the installation of your configuration inside the Kubernetes cluster. You can communicate direct with your pods. For example, if you install your own AWS network interface, I mean, like you will not manage as ISG, you will work with only pods and send the traffic based on the labels, based on the configuration inside in our Kubernetes cluster.
All right. So can we summarize what you talked about with the use case for Karpenter as a way of utilizing your infrastructure, basically your EC2 instances, more efficiently? Is that a summary of Karpenter?
Yes. In short version, absolutely yes. Just like the main goal of Karpenter provide for you just in time the load, just in time the resources, which can proceed with your load, with your applications, with what you exactly needed. And consolidation, it's what I said is very important feature which can help us to understand. For example, on this way, yeah, I have 4 nodes, and for these nodes I need 12 CPU. Maybe it will be easier to, for example, deploy new node with, I don't know, 16 CPU, and it will be cheaper than these 4 nodes. It's one of the ways how consolidation works. It runs simultaneously, simulation, how many resources I currently have, just like simulate that I requested from the scratch all of these resources. And again, Karpenter will communicate with EC2 API and figure out your configuration, your current installation based on all of these constraints, configurations is good to fit your current load. And try to achieve, the cheapest solution. And as I said, the target of utilization, like we will see in the demo, try to achieve, 90%, 80%, depends on the situation and depends on your configuration.
We also have a question from Pori93, and I think this is maybe jumping a bit ahead. We'll get to that in the demo, but are you installing Kubernetes or Karpenter as a Kubernetes deployment?
Yeah, absolutely. You install its like operator, its deployment. We will see in the demo. And when we speak about the configuration of the Karpenter, it will be the same as for ISG. You need some controller. In our case, it will be Karpenter controller, which we proceed with custom resources with CRD. We will see all of the stuff in our demo part, but yeah, in general, yes.
All right. Great questions. Keep them coming. Viktor is here to answer questions for about 40 minutes more. So keep the questions coming.
Yeah, and I prefer honestly just like to jump into demo because it's better to show, just like don't describe the slides and say it's working this way and this way. It's prefer to show how it really works. If you want to continue with me, you can scan this QR code or Gunnar will share the link.
Yes.
Yeah, and let's jump into my installation. First of all, I want to show that I already deployed 2 Kubernetes clusters. It's EKS. As I said previously, Karpenter is open source, but currently it works only with EKS. But we really open for contribution. And if you're ready to send pull request to adopt Karpenter for other cloud providers, we will be happy to merge it to our installation. But currently, and of course during the whole demo, we will speak about EKS. I have 2 Kubernetes clusters. What exactly inside is this Kubernetes clusters? The first one. First of all, let's review what kind of pod currently I have inside in my instances. I will use K as alias for kubectl, if you do not mind, like it will save some time for me. So what exactly I done by this command? I want to get all pods from all namespaces. And what we see that we have 2 pods of Karpenter. This one, so it's like it's deployment. Also, as you can see, we have some stuff in default namespace. It's called kubeops view. kubeops view, it's open source product, which will help me to visualize how many nodes currently I have and what's the pods spread between these nodes. If you're interested in this product, you can install in your Kubernetes cluster and see this configuration, this operation view of your Kubernetes cluster. Again, the link I think Gunnar will share with you in our stream.
Yeah.
Yeah, what else I have? I have the second cluster, and both of these clusters are absolutely the same. But I prefer to start from the second cluster because on the second cluster, what exactly I'm going to do? As you can see, I already prepared some comment. This comment have 2 parameters, 3000 and 500. Let me explain a little bit. So it will be, like bar script I will show in 1 second. And by this bar script, we will deploy 3000 of pods with a batch which will split of 500. So we will see 6 deployments, and in every deployment, we will have 500 pods. So I want to start this demo part because it will take some time, just like to schedule and request resources for 3000 pods. It's pretty huge amount. And let's back to first environment. I already configured provisioner, but we have not speak about the provisioner because when we speak about Karpenter, as I said, we need some controller. Controller is our this one, yeah, and also we need some custom resource. It will like to proceed what kind of configuration, what the limitations, what the restriction do we have, and it's realized through the provisioner. What we can do in provisioner, it has a lot of different configurations, different parameters, and I will very quickly brief review with you what exactly we can configure. For example, in this provision, I can say I'm prefer to use some family of EC2 instances like C, M, and R. And for example, how much of CPU I prefer to have for this installation. In my case, it will be 4, 8, 16, 32, and so on. Maybe I want to restrict what kind of availability zones I prefer to deploy my application. I know, like, for example, US West 2A, 2B only, Or maybe I want to deploy my application only on spot instances or on demand instances, depend on the what's exactly doing it. And also we have a lot of another configuration. I am not going to go through all of them, but want to highlight a little bit this one is limits of resources, how many resources I provide for this provisioner. But what kind of what's the provision do we have currently? Let's check it. I want to get provisioners, and we see I have default provisioner. Let's in detail review this default provisioner. I want to get its YAML, just like to see what's the configuration inside of this provisioner. So as you can see, I enabled consolidation, and we review how it works. Also, for limits, I say 1000 CPU. And also, I want to run only spot instances. And all other stuff, it's by default from default provisioner. And what currently I'm going to do? I want to deploy my first application. It will be very simple, small application. Let's a little bit scale. So we will deploy 10 replicas, 10 pods. With configurations that's from resource perspective, I'll request 250 millicores for CPU and 256 megabytes of memory. And from some restrictions, some limitations, I would say not selector, only where we have a spot instances. And let's deploy this application. Also, before we will deploy this application, I want to show you the logs from the Karpenter. Currently, it looks like in this way. We will review a little bit in deeper as soon as I create some event, because Karpenter will proceed with events that currently I need to request some resources. So let's deploy this application. kubectl apply -f, and it's my start application with 10 pods. So I requested, and I'm going to deploy this application. Let's switch to logs and see how Karpenter proceed with this request. As I mentioned, Karpenter understands how many resources do I need. And as you can see, Karpenter understands, okay, I need some resources for 10 pods. But how many resources exactly I need to fit this load? As you can see, Karpenter say I will need 2600, just like in case, two CPU and a little bit more than 2.5 gigabyte of memory. But what another very interesting point that Karpenter say I will need to proceed with 12 pods, not 10 as we saw previously here. Why? Because when Karpenter understand how many resources do I need, it also understand it's the current request, but this one, when I requested 12, Karpenter also calculate diamond set. And we remember diamond set will present it on every node. Yeah. So Karpenter just connected to EC2 API and currently figure out that for spot instances, Karpenter found 98 instances which can proceed with this load. And selected C5D X large. Let's see from visualizations how it looks like. As you can see, we added new node and put all of this load inside in this node. What will happen if I scale this application? Let's say, for example, currently I have 10, but I want to scale, add additional 50 ports inside only in this application. We just scale our deployment inflate, simple, super simple application, and let's say add additional 50 ports. Again, I prefer to switch to logs from Karpenter. And as you can see, Karpenter say, I will need resources for additional 45 pods. Why 45? As you remember from the presentation, I mentioned that when we see while we need to proceed with load, first of all, we try to understand what's the current configuration, what's the current resources do we have? And maybe we have some empty spaces and we can scale our pods inside these free resources. And Scalar found it. I mean, like Kubernetes Scalar found it. And for the Karpenter, we requested only resources for 45 additional pods. In this time, we will request a little bit more than 10 CPU and 10 gigabytes of memory. And again, it will add only one node. And in this case, again, we see 47 pods, not 45. But as you can see, something happened. Some cardon node, delete node. And if you're familiar with Kubernetes, you know when we cardon or delete node, it means like I delete some of the node. Let's review from visualization what's currently happened exactly. I see only one node which put all of these pods inside my node. So more than 60 pods currently run inside only one node. And from Karpenter perspective, like from the price perspective, it's a cheapest solution. Because Karpenter run, as you remember, I said for our provisioner, I enable consolidation. And Karpenter runs this simulation that my current load, like 60 pods, will be cheaper to run in one instance or on multiple instances. And based on from the price perspective, it's better to run on only one instances. But it's very good ask related to load balancer, because when we split our traffic, we also manage it through some not instances, and it will not be a good situation to have, I don't know, like one instance with, I don't know, like 100 pods inside these instances, and that's it. Because in case if I lost this instance, I lost the whole of my application.
Yeah.
And it will happen in this case. And we can manage it. We can do it. Just like you can, for example, make some constriction for the Karpenter. And for that reason, I want to move to the next part of my demo and show how you can do it. So first of all, before we move in to the next part, I want to delete this deployment, my inflate deployment. And I believe we will see that all of these pods will be disappeared. Yeah. And I also want to adapt a little bit my provisioner.
But I guess the previous example you showed, that could, for instance, be you running some sort of batch processing or something, where it doesn't really matter if you lose the node. So
Yes.
you just want to be as efficient as possible with the resources.
Absolutely. But for web application, it's not the best solution when you have only one node and you put everything inside this one.
Right.
For the second part of my demo, I want to show you another scenario. What the scenario is. I got this request a lot of time from our customers. So I have my EKS, yeah, and in this EKS, just like on spot instances, is much cheaper than on demand. But spot instances can be, like take it back to the AWS, because we have a lot of requests on this type of resources, this type of EC2 instances, and we can lose these instances. Can I do something to split my load between spot instances, yeah, for example, and on-demand instances? Or let's say 50-50. 50% will be on-demand and 50% I want to run on spot instances. And Karpenter can do it pretty easy and really quickly. And to realize this, first of all, I need to delete my default provisioner. Default. And I want to run deploy to another provisioners. Let me show what's exactly inside in these provisioners. I have two provisioners. It's demand and spot. For these provisioners, I say I want to add additional labels for my nodes. Like, for example, for spot, it will be 3 and 4. It helped me, to define the percentage, how to split traffic between spot and on-demand. And also, as you can see, I add additional configuration, kubelet configuration, and say max spot 30. What exactly it means? Previously, as I show during the previous demo, when we request some resources and it was only one node, in this case, I say, I don't want to run more than 30 ports per node. I also can do it through my deployment, for example, spread deployment and so on, but also can configure it through the through the Karpenter. And during our demo, we will see that inside in my node, we will not have more than 30 ports. Yeah, the second on demand, it's absolutely the same, but just like with values capacity spread 1 and 2. What exactly I'm going to do? Just deploy these two provisioners, kubectl apply minus f demand, this one, and spot. And currently, if we look at how many provisioners do we have for my Karpenter, we have 2 provisioners. What that means? It means, for example, you have your own different development teams, and you have only one shared cluster. And using different provisioners, you can manage how many resources, what kind of resources they can request from our EKS cluster. So through the provisioners, you can manage a lot of stuff. So inside in Karpenter, you can create a lot of provisioners. In our case, I want to show how we can not put all of the pods inside in one node, big node. And the second is like how I spread my load between on-demand and spot instances. And I'm going to deploy absolutely the same application, but in this time, it will request 600 pods with the same amount of resources, 250 millicores, 250 megabytes of memory. And as you can see, I also add topology spread constraints. And for topology spread constraints, I define that it's my custom labels called capacity spread. And I will split my pods between different nodes. Let's deploy this application. Kubectl, again, apply minus F, split 600 pods. And if we switch to logs, I mean like how Karpenter proceed all of this request, we will see a lot of requests from, I need to schedule 28 ports, 40 ports, understand how many resources do I need, 7 CPU, 7 gigabyte of memory, how many ports I can schedule inside in this node, and so on. And from visualization perspective, it will be looks like, sorry, we need to wait a little bit. We will see how we spread, my load between on-demand and spot instances. I also want to show you another terminal. Let me quickly show, and let's see how many nodes currently I have inside in my Kubernetes cluster. So what I did, I say, kubectl, please get me all nodes and show me the labels, instance type, and capacity type. And so what you can see, we see capacity type, and on the capacity type, it's on-demand or spot instance. Currently, not all of them is ready because we we request this resource, we need to onboard this instance, install kubelet, configure it, and so on. So as soon as all of these nodes will be ready, Kubernetes Scalar will put all of the pods inside this node. And just like I believe, as you can see, here we go. We have a couple of, not all of them is ready. I think we will see in dynamically how it adds maybe additional nodes or maybe run some consolidation and so on. But in general, what I want to show here, do you remember that I said it's not the best solution for web application to put all of your pods inside in one node? In this one, as you can see, we have 28 or maybe 30 ports inside in one my node, not more. And as you can see, we have another spread, how many nodes I requested, how many nodes currently I have in my installation. If I zoom a little bit, yeah, sorry. Yeah, so it's currently looks like in this way. So Karpenter requested all of this node and provide the right amount of resources just to give you to provide for you the resources from AWS. You would ask me what's consumption of these resources. I mean, like how many free resources I currently have. We can check it. I will use another command, and I need to back to my README file. Sorry, for this one I need. I think I will need some export. No, let me try just like capacity. If it works, no, it not works. As usual,
while you're doing that, Viktor, everyone, this is the AWS Nordics Office Hours. I'm joined by Viktor. Today we're talking about Karpenter to efficiently scale your Kubernetes clusters. And we've seen a bunch of different demos so far of how we can use Karpenter. Let's see if Viktor is able to get this working as well.
As usual, it's a demo. We can just like forget something or just like in real life do some stuff. So anyway, I want to do it. Let me try one more time. So I want to put the export and one more time to see what the resources. Yeah, here we go. So it's custom plugin for Kubernetes, which you can install and also use through the Crew. Crew, it's very close to package manager for your Kubernetes cluster to install additional plugins and so on. And as you can see currently from CPU request, we have 85%. So it means like I consume 85% across the whole of my cluster currently. And it's my consumption of resources. Of course, this instance, this application do not do anything. For that reason, CPU limits currently 0, but like we currently focus only on request. 89%, because Karpenter run this simulation, as I mentioned previously, for consolidation, and try to find the best solution, what amount of resources will be needed for your current load, for example, for this batch request and so on. And also, if we switch to this one to look at how many spots and on-demand, I'm not going to calculate and say 1, 2, 3, 4, 5, but as you can see, we have a couple of them. It's a spot instances. Some of them is on-demand. And it means in our case, we split, as I mentioned, like scenario between on-demand instances. For example, our application should never just like go down because it's very critical for us. But at the same time, I want to save some money and prefer to run some part of my application inside and spot instances. It's very common, I think, situation when we want to save some money, but also worry about availability of our application and cannot rely only on spot instances. Another part of Karpenter, it's like one of the very important to understand that when you work with ISG after scaling group, and when you define the list of spot instances, for example, you have to manage it manually. For example, say, currently I want to use C5 and 2x large instances. But what in case if tomorrow, I don't know, like Netflix will release some new show and will take all of these instances from this region of AWS? Karpenter will proceed with this request because Karpenter directly communicates with EC2 API and we'll understand that currently this instance on Spot is not available, but we have another list of instances. I don't know like how many, but we can see in logs how many instances available. Spot instance available in this region. And if you just like very carefully look at my demo, I said we have two different environments. It was the first one. Yeah, and currently we scheduled this way from visualization part, how many nodes we requested. We deploy our 600 ports, like our web application, and what's the spread, what's the request resources. But also, I run this one. It's my high load application. It's like batch request. I know like we very close to end of the month. And for example, every month we want to analyze some documents or some data, blah, blah, blah. It can be pretty, I don't know, maybe every month or maybe every quarter and so on, so on. And you remember I requested 3,000 ports with a batch for every deployment, 500 ports. Let's check how many deployments currently do I have in my cluster. Oh, something happened. Sorry, I will not be able to show it. I requested.
This is the joy of live demos, folks.
Yeah, it's not pre-recording, but yeah, it's real live demo. Looks like I forgot to make some configuration. Let's do some quickly troubleshooting. I figure out very quickly because I forgot to deploy my provisioner. Yeah, it's why for that reason we cannot manage and schedule all of my stuff. So what I want to currently do, I want to define some variables, and I need to define it's not this one. Yeah, let's use this one. And I will define the provisioner. So I totally forgot about the provisioner. So, and currently, if we try to get the provisioner, we will see that I have default provisioner, and the limitation of this provisioner, 5,000 CPU, and for kubelet configuration, 200 ports per node. Because if you're familiar also with Kubernetes cluster, you know, sometimes we cannot schedule some amount of ports because we are depending what the size of the instance. And inside the Kubernetes, inside the Karpenter, you can manage this stuff. Like, for example, define static way kubelet configuration, for example, 230 ports, or maybe you prefer to manage this stuff by dynamically. Depends how many CPU do you have inside in these nodes, and base for every CPU, you will define some amount of ports. Yeah. Maybe you have some questions.
Yes, I do. So there are no questions in the chat right now, but keep your questions coming. Let's see. But a question I have, first off, is how reliant are you on those Karpenter pods that you're running? So what happens if they break, basically?
As I mentioned, just like on the start, I just like let's see what the nodes currently I have. Let's get the nodes. So some of the nodes, as you can see, have 22 hours. It means like I prepared for this demo yesterday. And this node, it's my managed node group. So for default configuration, what exactly I have? I just like if we switch to official documentation, go to the docs and getting started with Karpenter, scroll a little bit, and we will see this one, the configuration. Let me zoom a little bit. So for my EKS cluster currently, what I have a managed node group where I deploy my Karpenter. Yeah. In my configuration, I have only as desired capacity only one, And for the demo and for this amount of resources which I requested, I say I prefer to use C5 2x large instance, but it doesn't matter. So very short, like in this case, if I lost the instance which responsible for the Karpenter, managed node group will up and run new instance where the Karpenter also will be provisioned, and we run our Karpenter controller and make sure that it's available. But from another perspective, what you also can do, if we scroll a little bit down, you see the Fargate. And it means you can deploy your Karpenter controller inside the Fargate, and Fargate will be responsible of availability of these instances. I mean, like you'll not care totally about managed group, not managed group, and so on, so on. It's like Fargate. Fargate, we totally don't care about our nodes. Like Fargate for us. Yeah, it's how you can like install and work with the Karpenter.
So there's a question in the chat as well, if Karpenter can drain spot instances before they are terminated.
Good question, and it's very often which I get during presentation of the Karpenter. Yes, you have to install additional tool. Currently, I don't remember, but you can go to FAQs, I think so, and find answer on your questions. But yeah, I tested and it's worked pretty fine. I mean, like it will run the signal that yes, this instance is going down, and your application have a time like 1 minute to proceed with like make sure like finish all work and like finish the sessions on this way. Yes, currently it works fine, but it requires install additional tool inside in your Kubernetes cluster.
All right.
Yeah.
We have a couple of minutes more to go. Should we see? Do we have any progress on the nodes?
Let me check. Not so much. Honestly, don't want to troubleshoot on the live, but let's try at least. So what I want to get the logs from my Karpenter currently. And I see some no provisioner files. Okay, that's fine. That's fine. Let me just like delete this lot and rerun it again. Where is it? So now I want to create. Yeah, so let's see. And deployments -W, just like to watch what will be happened. Also, let's switch to the logs. We're waiting for some logs.
All right. In the meantime, when would you say someone should use Karpenter? Is it for any type of workload, from the smallest ones to the largest clusters, or does it matter?
No, I would say it's for everyone. And currently, if you already have your own solution inside the cluster scaler, and you understand like Karpenter can solve some of your problems, you can migrate from cluster scaler to Karpenter. I will be very honest with you. If you already have your EKS cluster and your configuration of scaling is good for you, I mean, like it's fine, maybe you don't need to like today migrate because just because. No. But if your application has, like
Oh no, I think Victor froze. There we go. Are you with us, Victor?
Is for yeah, I'm here. Can you hear me?
I can hear you now. There we go.
So just like try to repeat very quickly again. So if you have your application with different amount of requested resources, and it's not like a static when you request, I don't know, 2-3 nodes and that's it, but your application is really dynamic from scaling perspective, it means Karpenter can solve is more efficient because it will provide, as I showed you during the first demo, with 600 pods, we like consumption 90%. So if you want to save money of your Kubernetes cluster, Karpenter can do it.
Oh no.
Internet gremlin have, yes, I don't know why, but
oh well, these things happen. So, all right, but with that, it's also time to wrap this hour up. And just quick review, Victor, of what we've done. So you've shown us Karpenter, a way to efficiently scale up and, or is it out? Scale out and scale in your Kubernetes clusters. And you showed us several examples of how you can actually do it in practice as well. We've shared the links to the demos in the chat, so please have a look at those examples. And of course, also check out the EKS workshop that we linked to earlier on as well. And with that, Victor, I want to thank you very much for joining me today. And thanks to everyone watching as well. And I hope you all learned a lot. I learned a lot, definitely. So, Victor, thank you very much.
Thank you. Thank you very much, Gunnar. I'm like a little bit worried that the last demo didn't work, but yeah, I think in general, understanding how Karpenter can do like manage amount of resources you learned today, and Karpenter can do a lot of stuff just like to save money and how you consume resources inside in EKS.
Great. Thank you, Victor. Thanks everyone for watching, and I will see you again next week. Bye-bye.